Well, it's a pleasure to be here. When I was accepted for this talk, I wasn't following Kirk. So now I'm like, well, was that the right thing? Am I in the right topic? Where do we go with this today? And how do you walk into the room and talk about DevSecOps and not mention AI today? And so I apologize if you're AI'd out on talks. I promise this one will be different. If it's not different, let me know, but I tried. I really did. This is all fresh, and it's new. When I originally saw the schedule, I was on day 2 of the agenda. If I'd have known I was following the Secure by Design talk track, I may have stayed on the right. Instead, I went to the left. I think it's still going to work, okay? But this is kind of my view of state of DevSecOps today. This picture I actually took a few weeks ago, 14th Street overpass down by the wharf in DC. This is the door that I saw. I snapped it and said, this is cybersecurity. And my wife said, what in the world are you talking about? I said, well, it's really easy. See, it's a neglected door. We have a system. It may or may not be keeping up to date. We've padlocked it and we've chained it, but it's open. So nothing huge is getting in there, but that door is still open to threats, right? I can get a pry bar in there pretty easily. It just summarized some things for me, and I thought, okay, if that's the state of things today, where do we go with our conversation? I'm going to piggyback on some of the things that Kirk talked about, but where I want to go today is what AI is doing. When I think about AI, it's not a transformer, folks, it's an accelerator. If you have systems in place today and you expect AI to just change it for you, it's not going to work. It's going to accelerate things, much like DevSecOps did with your practices back in the day. And here's the thing. When we get the initial reports back today, and this is industry-wide, this is not all going to be a GitLab presentation by any stretch of the imagination. We're seeing kind of an industry average comeback of, hey, it's been 8 weeks, 12 weeks, we're playing with AI. We're kind of seeing this 50% efficiency gain in new application development. Now again, your mileage will vary wildly from 0 to 80, right? Whatever that number is. But this is just something we're seeing. And out of the agencies that we've surveyed, so we run a survey every year, Global DevSecOps Survey, this is the latest responses that we got, is about 80% of agencies say, yeah, we're going to do this. We're going to do AI, or we're already in it from the perspective of Gen AI assistance. Okay, great. So if we see 80% of them trying to do that and 50% efficiency gains, that sounds great, right? Our goal is 5 to 10x. We want to accelerate that another 10 to 20 times from what we're seeing off the bat with this. Okay, so it's going to be a ways to get there, but this is what we firmly believe is going to happen when we talk about AI's impact on the industry. So today what I'm going to do is I'm going to snapshot a few things for you. Where are we? How do you use it to get to the point where you're seeing 50% plus, right? How do you get the gains out of it? And then where are we going? Because I think the future is somewhat breathtaking, right? We're in a period of time that I've said before is kind of like when the mobile phone hit, right? When the iPhone came out, things changed dramatically for us. This is a cataclysmic change. It is something that if you're not ready for it, is going to be huge. Now, AI acceleration, we're talking about acceleration. I want to also touch on refactoring today because I feel like it's really important. Developers refactor their code every single day. They're in it, they're changing it, they're updating it. What about refactoring some older? What if we get into memory safety a little bit? What if we talk about some of the things that are in our closets that we've not been able to prioritize? We've all got something like this laying around someplace, and there's initiatives for us, right? Whether it's cloud migration and modernization stuff or performance and scalability stuff that came out during the last 5 years with the pandemic and some of the stress it put on our applications. Technical debt, unsecured debt, vintage vulnerabilities. Folks, vintage vulnerabilities are not like vintage clothing. You can't open a store with them. Nobody wants it, right? So if we could wipe the slate with some of this stuff, wouldn't it be great? So I kind of want to take you down that road today while talking about AI. We're going to weave refactoring into the conversation. And just so we're all on the same page, Martin Fowler told us what refactoring is quite a while back, but basically it comes down to this. I want the application to change internally, but everything on the outside stays the same. The user experience is the same, the functionality is the same, but the application itself has changed. That's a pretty simple explanation. I can handle that. The execution of that's really tough. There's a lot of success stories out there about major refactoring. Okay, I'm not claiming any alliance with any of these organizations, but the stories are out there. I did a lot of research on this. And if you go back in time on any large-scale organization, you're going to find something, right? And for Google and for AWS and for Netflix, you can see this is the stories that they have out publicly about their refactoring. And if you're following what's happening with Google or you're following what's happening with Microsoft, Chromium's accepting Rust contributions now because they're trying to get away from C++ due to the memory safe issues. Same thing for Microsoft with the Windows libraries. Okay, we're watching this happen real time. Without AI's acceleration of this is going to take a long time. AI is going to be key to this. But it's hard. Back to the survey results. We've run this survey for years, and the responses are almost always the same. Like, I've been around GitLab for 7 years, and in Tanuki years, that's a long time, okay? I was there when it was very small, and we were DevOps. There was no sec, right? So this number has barely moved. In 5 years, we're still seeing, now it came up a little bit in the last survey, but it's still pretty close to this. Of a developer's time, we're only getting a quarter of it. Everything else is going to everything else. And so if we know that and we're trying to reprioritize these big refactoring efforts, we're in trouble. We don't get their time, we don't get their skill set, we don't get the testing components at the level it needs to be at. And if we're talking about now refactoring an application into a new language, chances are one of the two you're not real good at. So how do you get there from here? I went online and did a little search on refactoring projects that were out there. And this was one of the biggest ones I found. That's the first sentence, or one of the first sentences in the README. We're just going to hack at it and see what happens. I have a response. That really is me at my desk. I said, you got to be kidding me. This is how we're going to tackle our refactoring? Yeah, that's going to work great with AI. Hey, AI, let me know what happens. Go for it. There's plenty of refactoring techniques that are out there. This is only a handful of them. Okay, there's a lot of different methodologies to refactoring applications. And you know what's interesting is as I dug deeper into this, I actually spent some time in Stack Overflow and just a lot of developer forums. And every time I found the word refactoring, I found these other things. WTF, what a BPOS, and many, many other acronyms, some of which I didn't even know. I've enhanced my vocabulary. But there's two things that developers hate. Number one is technical debt, and number two is ongoing refactoring. So if you're not using a refactoring method that's proven, we have a problem. So knowing that we're refactoring things every day, this is where I kind of want to go today, and apparently my translation didn't work quite right. So if you see things that are pointing all over the place, my apologies. But there's three components here that really make this work. First is red-green, the idea of I've devised a test-driven development approach. The tests are defined up front because I know how the app acts today, and we're going to do like a time machine approach, right? As the code gets developed, we're going to go back and make sure that the tests that we pass on the back end align to the tests we wrote on the front end. So everything's red until it goes green. Once everything's green, you're good to release the new code. Kind of makes sense. Composing abstraction, the things here, the names aren't important. What's important is large code, scaled refactoring, huge projects. These are the things that are now on the table that a lot of us haven't wanted to talk about for a very long time. And they're on the table because of what AI is doing. Now, to date, if you read anywhere, you see code assistants popping up all over the place. There was one on TV last night, right? I'm watching, I'm like, oh, look, there's Watson on TV. That's great. We're cranking out a ton more code with AI. But if you're just focused on that code assistance in a vacuum, what you end up with is piles of code. You've created a new silo. You've created a new problem within your SDLC. So Knowing this, we can't take that approach. Where do we apply AI throughout the SDLC? Now, I'm going to snapshot this. We're going to go in and talk about various areas, but essentially there's the idea of a chat function and then applying AI functions across each and every component of the SDLC is what enables us to not have those piles of code just sitting there. Now, one other thing about this, though, okay, so we talked about the idea of applying it across the SDLC. The other thing is, what models are you using? A lot of times we go, well, we're using AI, it's going to be great, we're just going to use this model. Our approach at GitLab has been that we have to test each model to see how it responds, because it's trained on human code, right? Humans wrote this stuff. It learned various patterns from various places, and so we're applying different models throughout because we also see silos that can be created by using the same model for everything. So we're trying to keep the efficiencies up. So it's something that you may not have thought about as you're thinking about AI across the whole SDLC. What does that look like? So let's talk about where we are right now. This is not a comprehensive list. Okay, this is just some of the bigger items that I hear talked about regularly. And you'll notice up top, explain existing code is on the top above creating new code. When AI can help us understand what's in our existing code, that's the #1 thing people want to talk to me about right now. I've got code, those teams are gone. I've got code that was written in 1971. What do I do with this? I have code that was never commented. Oh, surprise, right? I actually talked to somebody a couple weeks ago. I said, oh, that was mine. I left that stuff there 20 years ago. My comment says, this code works, leave it alone. I was like, okay, thanks for helping. But these are some of the things that AI is doing right now. Automating unit tests. Same thing with code documentation. It can follow the code and actually spit out the unit tests real time. Analyzing root cause. So as somebody who's just been in pipelines a long time, a lot of CI/CD stuff in my life, if I'd had this 7 years ago when I started at GitLab, what a game changer. I spent nights just digesting and fixing what was wrong in automated pipelines early on. It can tell me in 60 seconds now. I'd love to get that time back. My kids would love me to have that time back. Suggesting fixes for those tests. So not only are we looking at what happened in the pipelines, we're also looking at the unit tests that failed and saying, hey, I think if you did this, it would fix it. And then vulnerability remediation. There's a couple different things with vulnerabilities that AI is doing now, from explaining how to remediate it to actually automating the process so that you can look at it and fix it. So again, this is just some of it, okay? But it's a great snapshot to kind of take us down a road of how to use it better. And I think this is where some of those efficiencies come into play. So code explanation is a great one. When we think about code explanations and tell me what this code does, my first prompt would be, tell me what this code does. And it'll spit something back at me. But that's the first option here. What if I said, I'm a Python coder, well, spit it back to me in, what would it look like if I wrote it in Python? Oh, okay, now I understand. I'm writing in a new language. I don't know this new language that I'm using. Can you give me an idea on the pattern, syntax, calls, methods, those kind of things? My favorite one up here, explain this concept to me like I'm 5. Folks, it works. I've seen it work, right? Just, hey, I don't get this. Help me out. Take me down to the most basic levels. Can I do this with my current environment? I've got my environment set up. My dev environment is ready to go, right? No, it's probably not. AI can tell you why it's not. Inputs, formats, is it expecting an array? Is this binary? What in the world are you looking for here? You can ask it ahead of time. Again, best practices for new code. If I don't know what the code is, if I don't know what I'm supposed to be putting in here, I don't know what the best practices are for developing new methods, maybe you can show me. And then, again, one other favorite, tell me more. Tell me more, tell me more, tell me more. Just take me one level deeper, one level. You've probably done this. Tell me more about that. Point to the previous answer. About that is a really critical phrase. The other thing is set the level of expectation on how you're being communicated with. So it's one thing to say, hey, tell me about, this code. Tell me how to refactor something. Tell me, fill in the blank, whatever it is. It's another thing to say, I'm a 400 level user. Don't give me 100 level answers. Let's go. Hit me with it. If I can't handle it, we'll back it down. So this is kind of an important thing as well, is setting the tone and setting the expectation on how your responses are going to come back. So when we get into code assistance, and part of the flow of this is if you think about refactoring an application, there's two different core methods that I've seen today. One is single step. All right, you literally highlight the code, right-click it, and say refactor, and it goes off and it refactors it. You better tell it how to refactor, though, because you're going to get interesting answers otherwise. The other is kind of the two-step method of explain this code to me, because I have no idea what that old COBOL does, and then let's prompt it with natural language prompting in order to get the new code created. And this is the method I'm seeing far more commonly used because it's more trustworthy at this point. And it keeps me in the loop a lot more, right? I can now really have more say. So as with anything else, be really conversational. Provide as much context as possible, because context, dependencies, transiencies, these are the things that get us in a refactoring. Ask for different approaches to solve a problem. I love this. Part of the reason I have had my job for so long is because I am really good at a keyword search. Folks, I can Google like nobody. I'm sure most of you can say the same thing. There goes that world. Welcome to semantic search. You now get one answer. Is it right? Is it the one that you would have picked from the top of your Google search last week? I don't know. And because of that, if you can ask it, don't ask it for one solution. Don't ask it to solve the problem. Ask it for 3. Give me 3 ways to solve that. Give me 4 ways. Let me pick what I know would work best in this scenario. If you're not prompting it that way, you're missing out. And then the prompt itself is very simple. I have this problem. Help me resolve that problem, and then either iterate on that or move to the next problem, right? Ask for more. So not real complex, but there's a lot of things that we're not thinking about yet, right? We're all kind of playing in this world, and some of us are further down the road than others, but this kind of stuff really makes a difference. Oh boy, here's the yellow screen. AI is not the answer to everything that you need AI to be the answer of. Non-determinism's a riot. I can ask the same question 6 times and get 6 answers. You just don't know. That's why I like to get it out of the way up front. Give me 3 different answers now so I don't have to ask you 6 times later. But you'll get different outcomes. So be careful with it, right? Ask with more context. Try different things to see what other answers come back that may be more efficient. Incorrect results. What? Can that even happen? Yeah, because your context was missing a phrase, right? 2 words can make all the difference when you're doing something like an AI prompt. Security problems. Oh, I wish I could tell you that AI's code is perfect. I wish I could. If you'd asked me 18 months ago, my answer would have been 70% of every line of code that was created by AI had a security vulnerability in it. That was 18 months ago. Clearly, we've made some progress, right? Things are a lot better, but this is still code that's going to have quality and security vulnerabilities in it. Now, the good news is AI iterates on its own code. We're going to go there in just a minute, and I love this part. The other one here that's really important is Big Bang. When we're talking about refactoring large applications, do not go and just shove it in. If you take a 40-page document and shove it into an AI engine, it will spit out a summary for you, and it's beautiful. Try it with code. Don't try it with code. It does not go well. This is more, hey, I've got 100 lines of code. I've got a single function, a single method, something where I can break it down, convert it, and move on to the next thing. It works well in that context, but if you try to go big, it's going to not go big. Did anybody get, was anybody able to stump AI on math? Anybody try that? Yeah. So AI, oddly, is better with fuzzy logic. It works really well with that. But when we're writing code, a lot of that is logic-based, right? That's what we do. So if we're having some problems there, we have to be careful with what we trust. And I was able to actually fool it with basic math. And at some point it agreed with me, but that was very odd, right? How in the world does that happen? All that to say, stay involved. It's about you. No matter what happens in the process, you have to be in it. David Carroll from CISA says, AI is just math. Ironically, it's math that's not necessarily always good at math, right? So it has no brain. We have to use our own. So moving down, okay, so we talked a little bit about code explanations and then about code assistance. So if you see it as break down the code for me, write the code, we got to test that code. We got to test that code. AI, I talked about, can do test case creation, failed test remediation, pipeline root cause analysis. These are some of the things it can help with right away. And having the full context up front, can you see why it's so important? Because if you're looking at it from a test-driven development perspective and it doesn't have the full context, it's really difficult for those unit tests to align to the tests you wrote up front. And again, it really requires a human validation. But there is something about this that really speeds us up. I'm a former QA guy. That's where I grew up in tech. I spent a lot of time. It turns out I'm terrible at building things up, but I can break things down like nothing. I don't have many friends, okay? This is a really important thing. When you can expedite that testing piece, your code can come out clean. And remember, it's not going to come out clean the first time. We're 3/4 of the way around a development circle here, from code explanation to creation to test. You probably know what the fourth one is. Okay, the fourth one being the security part of that, and we're about to start going around the circle. So today, we can get vulnerabilities explained to us. If we don't know what it is, explain it to me. Tell me how to resolve it. Tell me what it looks like. Tell me what class it is. Tell me more about it. Automatically remediate it. Oh, wait, we're in a log4j moment. Uh-oh, now what? That moment of time where we don't know where things are in our code base is rapidly going away. When you find it in one project, this is AI's beauty, and I love this about it. Hey, by the way, this is in 342 other projects. Would you like me to go resolve that for you a minute? Yes, please, right? We all had that panic during log4j, and that was the number one request that I got for a month, is how do I find this across my code base? It wasn't as easy then as it is now, and now the remediation is expedited, and all we have to do is go and fact check everything and make sure it's right. So now we're in the circle. We're going around. Okay, we're securing our code. We are now managing the process, we're auditing the work, we're validating the outputs of AI, and we've begun to go around. Once we get past this security vulnerability remediation piece, now we go back through the circle, right? The code has changed. Let's test it again, let's secure it again. The code has to change again. And we just start going around. AI is iterating on its own code until it's clean. Here's what I really love about that. Notice I put reduces shift left fatigue up there. For those of you who have been doing this for a while, shift left has been the term du jour for a while, and it was good. It's doing the right things. It's putting things far left in the DevSecOps world, right? So that things are secured earlier. We know that's part of the reason the developer scores are coming back so bad, is because they can lose a whole day on 2 or 3 vulnerabilities very easily. This solves that problem so quickly, okay? It's not the universal answer, but it takes us a long ways. And the more things get into the automated remediation side, the better. We're not there yet. I'll be straight up. We only can do that with, you know, the packages that we understand. So this is growing quickly though. And the idea of relieving developers of shift left fatigue is one of the things that has me really excited. So let me tell you a quick story. The story is about a cloud migration initiative, and I was at a contractors conference, and they threw this out there talking on a panel and kind of walked right past it. And I said, whoa, slow down. You went to a modern language, you pulled out of an old monolith in your data center, you moved it to the cloud, you started utilizing microservices, and you did that, you dropped 90% of your code base, which unto itself is amazing, right? That's great. But then the code scaled 50 times further and runs 100 times faster at scale. And this is one of those applications that gave us trouble once the pandemic began. Whoa. Oh, we did it in 6 weeks. Oh, how'd you do that? Oh, we had a little help from AI. Okay, these are the kind of stories that are just starting to emerge. Now, clearly, this isn't an attributable story, but this is a real deal. 2 other scenarios that people are evaluating right now. Okay, these are scenarios for groups that I'm engaged with all the time. One is the mainframe. We got a lot of stuff that's still out on mainframes. Assembly, SAS, and COBOL. Assembly's on that memory unsafe language list, and that gave it a little bit more attention. But how do we get this stuff? We're going to skip right over the data center and move it right to the cloud. Is kind of what we're starting to hear. These are the target languages we're seeing. A lot of Java, Python, and C#. All those benefits on the right side, though, what's happening is this is the code explanation piece and the code assistance piece being used in AI. Because a lot of times we don't know this stuff. When's the last time you used SAS or COBOL? Maybe you do, right? But a lot of us don't. And here's why this one's so important. During the pandemic, we called developers out of retirement, didn't we? I mean, we called a lot of them out. We paid them obscene amounts of money. They cleaned up. Here's the problem. 4 years on, we've lost a lot of those developers. Not to be indelicate, but they've passed away, some of them. Like, I've done the research. We lost a lot of those folks. That's a problem. How do we maintain code that's running there if we don't even have people who know the language? So, here's one of the other big ones. Native API and AI use. How do you stack API calls and AI on top of a legacy mainframe application that's written in a 60-year-old language? You can do it. I don't envy those trying to do it. It's got quite the runaround to get there, but it can work. Last one's firmware. Ada, embedded C, these are the 2 that I'm seeing most commonly. And I mean, if you just watch the headlines, you look at what's happening in the space with cars and hacking, you understand what's going on here, right? But this has now got the attention for critical infrastructure. Hey, wait a minute, there's Ada stuff running. What do we do with this? Nobody knows the language. There's no security scanner for it. Uh-oh. Last minute here, I'm looking at the clock. I think we're running a little bit over. Here's where we're going. Fully automated workflows with autonomous agents. What does that mean? It means that instead of you doing your configuration of code, and instead of you creating your backlogs, instead of you recommending your work to teams and people, instead of you writing the initial code draft and the initial tests, you use natural language processing up front to tell AI what you want, and you get to the point where it gives you an initial pass with known vulnerabilities before you start coding. This is not the far future. We talked about this on a GitLab event in June as the near future. So it's just something to look forward to as far as, okay, how do I work in this world? If we know all this information, what do we do with this? How do we use this system where autonomous, proactive agents are now helping write code before we even get our hands in there? And based on time, I'm going to cut it short, and I know we're over. I guess if you got questions, find me later.
Thanks for the talk. So I have one question. There is a difference between a human written code versus AI written code, where I as a developer, if I write the code, I love my code. Have you experienced after this refactoring, people complaining that, hey, it's AI written code, I don't know how to debug, give me more time. So did we end up spending more time in debugging later? Or because when people write the code, they know what they're writing, so debugging becomes easier. Now with AI written code, are we seeing an uptick on time in debugging?
Yes and no. So yes, AI, what's nice about it is it tends to iterate and grow based on your syntax and on how you code. So if it's not learning from your code, but it's learning from how you code. And a lot of times that helps. AI is iterating on its own code. That's really helping us as well. It's making a huge difference on when you get involved, because right now you're probably involved earlier than what you will be soon. And I think the third thing is just, it's always going to be that. to some extent, right? AI will continue to grow and learn and change, but there's always going to be, this is the way I do things, and it doesn't do things that way, right? It doesn't write the letter that I would write today. So I think that's going to be an ongoing thing. I'm not sure when that changes. That's my honest answer.
One of the comments I wanted to make, when you're looking at legacy code, I was surprised you were only taking a technology solution, because usually the backlog of maintenance on that code is decades. So what I did in a former life, so to speak, was, this was when AI first came out, was to go out to the users and build the rules with them using AI to isolate that horrible code in the back end. And then once you know the rules, you can move it to anything you want to. You don't have to interpret the code because you know what it's supposed to be doing for the user. And you're not worried about the dead code because you find out what they are and aren't actually using. So expanding that beyond a pure technology solution is something that should be considered.
Yeah, absolutely agree, and that's something that was really hard to shove into 25 minutes. But I fully agree with you. Yeah, there's a lot more to this topic and a lot more to the approaches of this that need to be considered, depending on the environment.